So this is the next big rule under order differentiation, and we call this the product rule. And as the name suggests, we use this rule when we are trying to differentiate a function, which is basically the multiplication of two individual functions, right? For example, you have something like this here. Let's start off with a simpler example. Let's say we want to multiply it. We want to differentiate y is equal to let's say x plus 5 to the power of 3 and x plus 1 to the power of 2, right? Again, we're not going to expand these individually and then differentiate it. Now you can use the chain rule for something like this, because it's not as if we've got a function inside a function. We've basically got two separate functions that are just multiplied together, right? If we just have this, we know how to differentiate that. If we have just this, we know how to differentiate that. But now we have it together. So how do we differentiate it when it's multiplied together? And the answer to that is this product rule. That's what we do here. So this rule basically says that if you want to derive a function that is multiplied by another function, what we do is we find the derivative of both these functions. Okay? We find what f dash x would be. So I'm just going to write that here. So we find what f dash x would be, or the derivative of fx. And then we'll find what the derivative of gx would be. So that's g dash x. And then what we do is, so we've got f dash x and gx, and we've also got fx and gx. Okay? Now what we do is we multiply these two together, and then we multiply these two together. And we add those up, and that gives us our final derivative. Okay? And we're going to basically use this rule and go through these three questions so it makes a bit more sense. Okay? So this first one here, we've got y is equal to x squared times x minus 1 to the power of 3. So we can immediately see that we've got a function here and a function here, and they're multiplied together and want to differentiate them. Okay, so what I like to do usually is I'll say, I'll split these two functions up into the letters u and v. Okay, similar like how we did at the start of the chain rule. So now I'm going to say, let u equal x squared. Therefore, u dash, or the derivative of u, is equal to 2x. Okay? And we're going to let v equal x minus 1 to the power of 3, which means that v dash, or the derivative of v, is going to equal 3x minus 1 squared. Okay? And now, as it will suggest, to put this together and differentiate it, we do this times this plus this times this. Okay? So dy over dx is going to equal 2. So let's do u dash first. So that is 2x x minus 1 to the power of 3 plus x squared. Or we can do 3x squared, and then x minus 1 to the power of 2. Okay, now we can sort of simplify this a little bit. We've got x minus 1 squared common, and we've got x common there as well. So we can take that out. So we can do x and x minus 1 squared. And what have we got left over? We've got 2x minus 1 plus 3x. Which you can actually simplify more. And this becomes x minus 1 squared. 2x plus 3x becomes 5x. And then we've got minus 2. So there's your final derivative. Okay? It's nothing too crazy, just a new rule for a different type of functions. We're just gradually building up our differentiation knowledge and just sort of building our way so we can differentiate any type of function that possibly is. Okay. Second one, same thing. We've got y is equal to x plus 2 times x plus 5 to the power of 6. So again, we can clearly see that this is our one function here, which is I'm going to call u, and that's multiplied by a second function here, which I'm going to call v. Well, let's go through the same process. Let u equal x plus 2. That means that u dash, or the derivative of u, is just 1, right? And then we've got to let v equal x plus 5 to the power of 6, which means that v dash, or the derivative of v, is equal to 6 bracket x plus 5 to the power of 5. Okay, now let's go through our multiplication again. So dy over dx, and since we're adding them, it doesn't matter which order you do them in. So it doesn't matter if you do u times v dash first or u dash times v first, because you're adding them anyway. So I'm going to multiply these two together first, my derivative of u and my v. So that's just 1 times x plus 5 to the power 6, which is just x plus 5 to the power 6, and plus, we've got 6 x plus 2, and then x plus 5 to the power of 5. Again, we've got a common factor here. We've got x plus 5 to the power of 5 common, which leaves us with x plus 5 plus 6x plus 2. Once again, we can simplify. That becomes x plus 5 to the power of 5. And over here, we've got x plus 5, x plus 6x, which is 7x. And we've got 5 plus 12, which is 17. You can just rewrite that as a normal bracket, and there's your derivative for this function. Okay. Last one's pretty much the same thing. They just try to make it a bit harder, but we already know how to deal with square roots. So we've got f of x is equal to 10x squared. And I'm just going to already just rewrite this as 2x minus 1 to the power of 5. Okay. So again, this is our u, and this is our b, and we're going to differentiate them, and then put them together. So let u equal 10x squared. That means that u dash, or the derivative of u, is equal to 20x. You can also write it as du over dx if you prefer. You can write it that way. It's going to give you the same thing. And let v equal 2x minus 1 to the power of half. Oops. Sorry about that. Let's just rewrite that one. It's not rubbing out for some reason. Let's just do that again. Okay. That means that v dash, or the derivative of v, is equal to, let's have, is equal to half times 2 times 2x minus 1 to the power of negative half. I'm just going to clean that up a bit first. Half times 2 is this 1, so this will just become 1 over square root of 2x minus 1. Now we can multiply this together to get our derivative. So f dash x is equal to u dash v, which is equal to 20x times, we can rewrite it in start form. Now we don't have to write it as a fraction. So I'll just do 20x, then square root 2x minus 1 plus 10x squared over 2x minus 1. And this one we probably can't simplify. If anything, you can maybe take out 10x, so you can do that. You can take out 10x as a common factor. So then we're left with 2 square root 2x minus 1 plus x over 2x minus 1. And there's your derivative for this final equation.